All right, everyone's filing in. We're just going to give it a couple more seconds before we get started. We've got a big group today, so I want to make sure everyone is logged in. All right. Hello, everyone. Good morning, good afternoon, wherever you're joining us from today. We're happy to have you here. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got Oracle ACE Pro and Viscosity Managing Consultant with us today, Gary Gordhamer, presenting What is an AWR report trying to tell you? This is a live webinar, so feel free to submit questions in the Q&A box. Gary will have that open on one of his many windows over there, one of his many monitors. So he'll monitor it as he presents. If you have any other issues, Coleman and Rob are on hand from NYOUG to help manage any other questions. But otherwise, try to keep all your questions to Gary in the Q&A chat box. All right, my name is Monica Lee. I'm the marketing director here at Viscosity. We are a full Oracle stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex. We perform near zero downtime migrations, lots of projects on performance tuning, high availability. We've also got decades of experience with infrastructure, including engineered systems, and we've been upgrading our customers to Oracle Database 19c and prepping them for 23c. And we also host monthly workshops through orapub.com. I'll tell you a little more about us in a bit, but co-hosting with me today are NYOUG board members Coleman Leviter and Rob Edwards. Rob is going to tell you a little about NYOUG, and then I'll quickly introduce Viscosity to you.
Thank you, Monica. I'm Rob Edwards, treasurer with NYOUG. NYOUG was formed in 1984 for the exchange of ideas, assistance, and support among the users of Oracle software products. We can be found on Twitter, Meetup, LinkedIn, Facebook, and on our own website, NYOUG.org. And we'd like to thank Viscosity North America for co-hosting these webinars with us for the last 3 years. Monica?
Awesome. Thank you so much, Rob. If you're not familiar with Viscosity, I'm going to try to make this quick, but hopefully there's something here that interests you or we can help you with. If you are familiar with Viscosity, you know it's my job to remind you we're here. So bear with me for a couple slides and then we'll get to today's featured presenter. All right, so Viscosity is built on these 3 main pillars: data, apps, and cloud. If you see anything in either of these 3 columns that you work with regularly that you think you may need help or consulting with, please let me know. I'd be happy to connect to you with some of our guys like Gary. And anything across the bottom, we do across all 3 pillars: managed services, training, proof of concepts, assessments. We do a lot of cloud assessments, people planning or prepping to migrate to the cloud, migrations, upgrades, all those things, kind of our bread and butter. On this slide, I've got 6 of our consultants and executive management. These folks represent consultants that Oracle has deemed thought leaders in the Oracle database community. They present all around the world on Oracle topics, write blogs, books, case studies, anything to continue helping the Oracle users community and Oracle customers. Oracle gives these titles of Oracle ACEs to people who do not work for Oracle and who have proven their value to knowledge share and development to Oracle users like you. Alrighty, this page, I always just like to point out Oracle License Management. And I say this every time, please work with a partner. If you already have a partner, if you don't, obviously I'm going to plug Viscosity, but Oracle license management, it's tough. It's not fun. I would always turn to a partner who does it routinely, who knows how to get you the best discounts, who knows how to really work with Oracle and a VAD to get you what you need, all you need, and to get it at a good price. And then we can also follow up with you to make sure you're taking advantage of your investments. So definitely go through a partner like Viscosity anytime you're interested in purchasing licenses or hardware. And then also we do provide managed services in varying degrees to our customers. Okay, on this page, I've got some of our most recent books up. 3 of them are pretty new as of this year: Oracle Database Performance Tuning, Upgrading Oracle Databases, and Oracle on Docker. Those all came out this calendar year. And then finally, you can find webinars like today's and all of our past webinars on www.orapub.com. Orapub is where we host a lot of live virtual classes. Gary's done a few for us. Some of them are like 3 days long, half days. A lot of companies will reimburse you for that training. So I always recommend taking a look at Orapub's list of live virtual classes. Also, if you sign up as a free member, you have access to our entire database of recordings for webinars like this and slide decks that accompany them. But also when our guys go and speak at our user group conferences or Oracle Open World, we ask for their slide decks and we share them here. We also have a lot of guest speakers that speak for Viscosity, also NYOUG and Viscosity co-hosted events, and we post those here as well. So check it out. Be sure you go here. We should have this one posted within the next 24 to 48 hours, and you'll get an email when it is posted there. So definitely check it out. You can look at paid memberships as well. And I would always recommend asking your company if they would be able to reimburse you. They're not too expensive for annual memberships, and they give you discounts on the live virtual classes. All right, and finally, some of my teammates and I will be at Kscope, which is outside of Denver, like actually 10 minutes from the Denver airport, in Aurora, Colorado. If you're not familiar with ODTUG, you can go check them out. But if you're there, come by, stop by the booth, say hi to me. It'll be nice to see you all in person if you are there. And if not, we'll see you here again at the next NYOUG Viscosity webinar. Right, Coleman and Rob? All right. And then events.viscosityna.com is where we post all of our upcoming webinars, workshops, conferences, etc. Really good one-stop place to register for all of our upcoming events. And I think that's all I've got. So Rob, would you love to introduce Gary to everyone?
Yes, thank you. Gary is a managing principal consultant at Viscosity North America. He has spent much of his career focusing on the enterprise application landscape and business process digitalization. Gary's technical experiences range from Oracle E-Business Suite, middleware, database, and related technologies for the last 19 years. His professional background covers many industries, including healthcare, manufacturing, utilities, and government. He is an active member of the Quest IOUG database and technology community, serving on the advisory board. Gary is an Oracle ACE Pro and frequent presenter at Oracle Open World and user group conferences. Gary, over to you.
Thanks. Let's see, make sure you guys can hear me. Yes, thank you. Thanks, Rob. Thanks, Monica. Thanks for hosting us here at the NYOUG. Great to be with everybody. As I said at the beginning, if you guys have questions throughout, please post them in the Q&A. And I will try to get to those. This is a new presentation, so I'm open to all feedback. I do make a lot of changes to my presentations based on questions and feedback and try to keep them updated. And the slides will get uploaded, as Monica said, so those will be available after the presentation. And I just, on this part, just please feel free to reach out to me. I'm pretty easy to get a hold of. I'm available on Twitter, LinkedIn, and my email address is in here. And I also have a blog too. So feel free to reach out to me in any of those locations. Let's see here. We'll skip past all the stuff Monica is. So we're here to talk about AWR reports, but I'll say this session's a little bit of a story, right? So this happens a lot. I get pulled in with a number of customers on this all the time. And in my database career, this has happened a lot. There's a problem with the system. The application isn't working correctly. Maybe it's hanging, users are complaining. There's a conference call, everyone's brought onto the call, and the all hands, what do you see, what's going on? Maybe the DBAs say, hey, the database is slow or unresponsive. They end up killing maybe a few sessions, and then the application returns to normal, and the management says, what happened? How can we prevent this? What can we do to make sure this doesn't happen again? And so, as a DBA or maybe as a developer, we look to our tools and we say, well, what tools can help me find out what happened? And what are they trying to tell me, right? So we're going to talk about AWR, but we're going to talk about some other things, other tools also kind of throughout this presentation. Like I said, it's a little bit of a story of what can my AWR tell me, and maybe what can't it tell me. So what do you need to collect? So for this information, will an AWR help you? Here's a top of an AWR report. If you haven't seen one, they're generally in HTML. There is a text-based version, but there's a lot of information. If you haven't quite looked at an AWR, there's just a ton of information in there. And a lot of times I get asked, what is this data for? What is it trying to tell me? So let's start with a little background about what is in an AWR report. Where does it come from? So Oracle has been around a long, long time as a database, and it's probably one of the most instrumented databases out there. I've been to a lot of sessions. I talk to people about things like Postgres, MySQL, SQL Server, etc. This is one of the areas that Oracle is just by far ahead of everybody as far as what's called instrumentation, or knowing what's going on inside the system. And there's a couple of views here, $sesstat and $sysstat, right? So sesstat is session level information. A session logs into the database, it does some work, and there's a bunch of statistics collected while that session does its work. And when the session closes, those statistics get flushed. And they generally get flushed into the $sysstat area. And sysstat is system stats. What happened across my whole database? These are cumulative. So both of these are cumulative sets of statistics, right? So sesstat and session stat, the session logs in, it runs one statement, it runs another SQL statement, there's some time it waited, then it runs a third SQL statement, then it closes out. The statistics are cumulative across all those different statements that have run, and maybe some of that wait time, et cetera, or think time where nothing happened. Those are all accumulated up. Sysstat is then all those session statistics brought into the system level, plus some other system statistics. Again, they're cumulative statistics. So, it read from the disk, did a second read, that's now counters at 2, it did a third read, et cetera. Those keep growing and growing and growing. In 19C, there's 2,036 statistics collected. In 21C, there's over 2,200. That's about a 10% growth. I will tell you in 23C, there's another at least 10% growth. So Oracle continues to add more instrumentation to the database, more information collected, et cetera. In general, if you go to the manual, it'll say those statistics are in these couple areas, right? So there's 9 areas here. There's actually a few more if you go kind of dig into them, but these are the 9 areas that the manual talks about. So user statistics, things about the session, the connection, the actual user connected database, redo, that activity of how do I undo or redo this work that has to happen if I have to roll back or roll forward the database. NQ work, which is those things that get in line, right? What's in line? Why am I in line waiting for something? Cache, anything to do with what's in memory, right? Caching, and how did it get into cache? How to get out of cache? Was I waiting to get something cached? Did something have to be freed up in cache? Things at the OS level, these would be like disk IO, waiting on CPU, other processes taking time, etc. Rack, this is things to do with the cluster, maybe global weights or global cache block moves, things like that. SQL statement specific, this gets into things like parses, or maybe literals getting changed into variables, or variables getting changed to literals. Things like that. Those are all SQL type metrics. Debugging, this is pretty low level stuff. Debugging metrics, there's a ton of those. And then instance level metrics might be things like the total memory footprint for the instance, or other things that are just specific to that instance. Again, with like a rack, you're going to have multiple instances. And I see there's a question already. Do you need the DB and T, basically the tuning and diagnostic pack to run AWR? And you do need the tuning and diagnostic pack to run AWR. It is a licensed product. If you don't have the diagnostic and tuning pack, then I would say look at Stats Pack. Stats Pack is a very similar tool to AWR. There's a few differences, but it actually works on the same idea. Stats Pack takes vsystat and vsystat data and collects it along the way. So we'll talk a little bit more how AWR does that. This session isn't specifically about Stats Pack. Maybe I should do one about Stats Pack, but it's a very similar tool that's not licensed. Okay. But the main takeaway here is there's all this instrumentation happening real time, right? So as sessions are doing work, these metrics are collected at the system level, they are collected and they're in the database, and these views, systat, systat, has that information. You can go query it real time, and they're cumulative. So the big takeaway here is they're cumulative statistics, right? So if you're looking at like IO bytes read or IO bytes written, those are cumulative since the instance started up. So then what's AWR, or Active Workload Repository? So we talked about those $V dynamic performance views. They're in memory. When I shut the instance down, they go away, right? So I start the instance up, that counter, like disk IO read, gets bigger and bigger and bigger as reads keep happening. And then I shut the instance down and it goes away. And they are cumulative. The AWR is then these DBA HIS tables. They're stored in the syssox table space. They're persistent. They collect values at intervals. So instead of collecting what was that at the moment I shut the database down or I started up, you set an interval, and the default is every hour. So basically every hour it says, okay, how many IOs is it at 12 o'clock? It's 50,000 IOs. Okay, now at 1 p.m., how many IOs is it? Oh, it's 60,000 IOs. Okay, now at 2 p.m., how many IOs is it? Oh, it's 62,000, right? So in this 1 hour, I did this many IOs, this hours I did less, etc. So it collects that number at a snapshot. It doesn't collect all the data in between. It just says at this point I was here, at the next snapshot I'm here. And again, those snapshots default to 1 hour, and you can modify that amount of time if you want to do more frequent snapshots or less frequent. When the instance restarts between intervals, right? So maybe my disk IO read was at 50,000, and then I bounced my database, right? And then that next interval at 1 o'clock comes up, and now my IO reads is at 1,000. Does that hurt things? Well, I lost some information there, right? Because I don't know if that 1,000, if the instance was restarted like 1 minute after the hour or 40 minutes after the hour. I only know the reads since it was restarted. I don't know what's missing in there. So you will lose data when you restart an instance. But AWR is smart enough to not give you bad reports, right? So if I were to compare those two snapshots and the instance was restarted in between, if the old number was 50,000 and the new one's 1,000, it doesn't say, oh, you did negative 49,000 reads in that out. It knows enough to know that the instance was restarted, and it'll use the data collected to give you as much as it can, but realize you are losing data when an instance restarts. Okay, so hopefully this just gives you a little background on AWR. And then we're gonna get back to that story. Like, how do I use this AWR? And then we're gonna use a little analogy here. So life is a highway, right? Hopefully you've heard a song like that, maybe in popular radio, life is a highway. So we're gonna use the highway here as an analogy for our database. And our road system here is like our database, right? So there's many things going on. The road system can be very busy or very quiet. And then cars on the road are like our sessions, right? So and when we take a trip, that's kind of like a SQL statement. So don't get too hung up on this, but we have cars and we have trips, and they're kind of like sessions and SQL statements in our analogy. So the question is, what does an AWR look like in this world, right? So I think this is something we can at least relate to. Most people drive in cars, get on roads, they use things like Google Maps to figure out their way to get somewhere, et cetera. And sometimes the road looks like this and it's kind of busy and we're not moving as fast as we would like. And other times it's just a deadlock and we're not going anywhere, right? And so to me, these are analogies of those Oracle AWR reports. Sometimes we had an incident and I have an AWR report. The incident felt like this. Did the AWR report give me the information to tell me what was going on, right? So that's kind of, we're going to use this highway analogy as our story for what does this really look like, Gary, and how do I use that data to help make decisions and help find out what happened, right? So I mentioned like a car. If a car is our session or our SQL statement is our trip, et cetera, well, the car is instrumented. Just like I mentioned, the Oracle database is instrumented, cars are instrumented, right? So in the car, you have all kinds of information available to you. Maybe the oil pressure, maybe is your headlights on or off? What is my current speed, miles per hour? Are my windows open or closed? Are the parking lights on? What's the temperature in Fahrenheit inside the cabin? And what's the temperature of the engine? How many RPMs, right? So there's lots of metrics available in your car, believe it or not. There's tons and tons of these. Not all of them are visible, right? So, you know, if I just look at my dashboard, I might only have like miles per hour and RPM and how much gas I have. But believe it or not, the car is collecting a lot of these. And if you take it to a dealer, they hook up a computer to it, and a lot of this other information is exposed to them so they can diagnose this, right? So this is very much like what a DBA is doing from the database. You know, someone sends a SQL statement, all they know is how quick it returned or something, but internally there's all these other metrics collected. So just a few comments about metrics then, right? So some metrics are very constant, right? So if you look at like something like speed, that might be very constant over time with very few variation. I get on the freeway, I go the same speed, and other times it can change rapidly as I drive. Something like headlights on or off, again, very consistent. Other metrics might change, like cabin temperature or engine temperature. They might vary a lot, right? As you're driving, your engine temperature might go up and down a lot. Your cabin temperature might change. You open the windows, et cetera. And then also notice the way these measurements are annotated, or the quantities that they're used in, right? So something like cabin temperature and engine temperature are both degrees Fahrenheit in this case. If you're outside the US, maybe that's Celsius, degrees Celsius. But they're not metrics just because they're both degrees. I wouldn't use them together. Like even in my car trip, I wouldn't say, well, was the engine temperature comfortable and was the cabin temperature comfortable? Even though metrics might be in the same measurement, I have to be careful of how I'm comparing them or using them, right? So again, just using that car as an analogy for here's our set of metrics. And here at a session or a SQL statement, I run that statement and all of these metrics inside of Oracle are getting collected. So now let's put this together. So I have my cars and I have a section of road here, and the cars and the SQL statements are going to go into the database. The cars are going to go on the road. And so my AWR report is a collection of these metrics of what's going on the road over an interval of time, right? So you can see here at the bottom, I have a few brackets to kind of show some intervals of time, right? So at this point in time, I'm going to take a snapshot of all of these guys' metrics, right? What is all of those metrics, each of these instrumented cars, all these metrics here, and then at the end of this interval, I'm going to take another snapshot. So, you know, this is just an example that we're going to use as analogy. So hopefully this example then gets you to the point where, okay, if I understand this, then how I'm reading AWR helps me understand what it can be used for. So here's a mile per hour metric example, right? So I have some cars on my road. So this is some statements running my database. And you notice I kind of annotated them for this purpose. What is the speed of each car at that moment, right? So the speed limit in this snap 1 to snap 2 of these cars. And so if I look at an AWR report between snap 1 and snap 2, again, these metrics are cumulative. So my cumulative miles per hour is 289 miles per hour. And then you'll see something like average, my average per session or per transaction or per SQL statement, depending on the metric, right? So my average here per car is 48.1 miles per hour, right? So if I'm using this report, if I get my AWR report from this piece of highway, I'm going to say that my average per car was 48 miles per hour between snap 1 and snap 2, and my total cumulative miles per hour was 289. So of those, which is a value, right? So depending on if I want to figure out like were cars moving fast or slow, I might look at that average, right? If I want to know like, was this cumulative helpful? It's not as helpful unless I know how many cars were on the road, right? So this gets back to, how do I use these metrics, right? So having 289 cumulative miles per hour, not as helpful. Now, what if I do between snaps 1 and 3, right? So again, I can run an AWR report from any 2 timeframes. So now I'm including a wider range, right? I want to know about all the data, all the things that occurred between this wider range. So it's cumulative. So now notice my cumulative miles per hour is higher and my average per car is higher. And that makes sense, right? Because I increased the number of vehicles, but I didn't increase them by that much, right? So again, there's more data here that might be easier to understand if we look at that bigger picture. And if I look at the couple between the first steps here, I have 1, 2, 3, 4, 5, part of this larger vehicle, this bus maybe. So 5.5-ish things happen between snap 1 and snap 2. And then when I add snap 2 and 3 in, well, there's 1, 2, 3 and another half, right? So my miles per hour went up pretty high, but my number of things, my number of cars there didn't increase as much. I didn't double, and hence my average went up, right? So again, just analyzing this kind of information requires me to look at the bigger picture, right? So a lot of times people open an AWR and they look at 1 or 2 metrics and they go, well, this tells me that. And that's kind of tough, right? Everything's always in context, and we'll show a few more examples, but hopefully the takeaway from here, metrics are accumulated, right? So I have all these cars and I'm getting their miles per hour. These metrics are cumulative. And then I get averages in my AWR, and then they're based on snapshots, right? So what was the cumulative at this moment at the beginning of snap 1, and what was the cumulative at this moment at the end of snap 2 there, right? And it's hard to answer some of these questions, right? Is the speed of the road good? Maybe, right? So you're saying like 48.1 versus 56.1. So notice I changed my window. Does that mean by changing my window, the speed got better, right? Does that mean the road is running better because I looked at a bigger sample size, et cetera? Are there cars breaking the speed limit? Well, I can't specifically tell you that, right? I can summarize or maybe guesstimate, right? I can guesstimate that if my average is 56, there's probably somebody breaking the speed limit, right? If it's 55. But with this first one, I can't specifically tell you that. I mean, it's likely, but I don't know the speed limit of those cars, right? All those individual cars are going those speeds. That's not in my AWR report, right? That's the data that was accumulated, but I don't see that. And other cars going below the speed limit. Again, I can guess, but I won't know that, right? So again, an AWR is helpful for some things, but some of these other questions I can't answer with that AWR. So time model. So this gets into time model. Again, if you have questions, pop them into the chat. We'll kind of keep moving along here. Oracle talks a lot about the database time model. The time model is very important. It's very useful. It's really talking about where time was spent inside the database, right? So you have a server, you have the database running, and then you have actions, right? Sessions running SQL statements, and they're using time. The question is, where did that time go? So that's the idea of the time model, is my session is taking up time, where did that time get spent? But not all metrics are time model metrics, just to be clear, right? So I think of time model as resources used, and specifically time resources, right? So when I look in the report, I might see something like bytes read from cache. That's not a time model statistic. I'm probably still very interested in that, right? Do I want to know how much cache was used, how much time, how many bytes was read from cache? Was that efficient? But it's not a time model statistic, right? Whereas something like disk file operation total wait time is a time model statistic. That's saying that part of my time was spent waiting for this disk file operation. And so in OEM, we often see graphs like this. These are ASH graphs. And we'll talk about ASH a little bit later. These are not AWR graphs. This is ASH. And there's a reason that's ASH, because ASH gives a much more granular real-time detail. Notice again, AWR is cumulative data at a particular snapshot time. And so there are AWR graphs in OEM, but they're huge, right? They usually span like maybe a week or a couple of days or something, and you're seeing data points at very high level intervals. ASH, you'll notice this ASH report is giving me, what is this, 12:42:00, 12:43. So this is giving me a minute, and then inside that minute, right, there's individual sections. ASH in this case is usually a 10-second interval. I'm not sure if this graph, because in OEM, you can change the graph size. So I don't know if this is exactly 10-second intervals. It might be 20-second, but way more granular than something like AWR. And I would never set AWR up to be like 1-minute snapshots. That's not really appropriate. Generally, the lowest I've seen AWR set is like 15 minutes, which is very granular. A lot of people that have high transaction systems might set it to like 30 minutes. So I'll say 1 hour is the default. I don't see too many people go beyond the 1 hour time frame. A lot of people go to like a 30-minute snapshot, and a few people go down to a 15-minute snapshot. But the AWR is giving you some time model data, but it's not that real time, like what's going on right now, right? It's more of that historical data. Okay, so in that AWR, we talked about these 2,000 some metrics. I'm going to put them into a couple categories of metric types, right? So these are just ways to think about the metrics. So we mentioned that DV time model. So weights generally are in that DV time model. This is, I want to do something, my session wants to do something, but it can't do it. I want to read from the disk, or I want to do an IO, but the disk is busy. I have to wait. I need CPU time. I can't get it. I have to wait. Those are all weights. In my analogy here, that's like my car is at a stoplight. My car is waiting on traffic. I'm on the freeway. I should be going 55. I'm going 35. I'm waiting on traffic. Those are all weight metrics, right? Resources, these are things that are consumed. There's generally a limited quantities, right? So CPU used by this session, that's a resource. How much did I use? Session PGA memory, how much PGA memory did I use? That's different than a weight, right? So weight was I wanted to use it and I couldn't get it. But when I did get it, how much did I use? That's the resource. How much did I use? And so a good example of my analogy is like, how much gas did I use, right? When I drove, how much gas did my car consume? Those are resources. Speed, the rate at which something is happening, right? So this is another measurement in my AWR. How fast did things go when they did happen, right? So something like redo write time, et cetera. This is something, maybe disk write time. This is something that's like, was that fast or slow? Was I waiting a long time for that, or did that happen quickly? And again, in my analogy here, that might be like miles per hour, right? Is my system running quickly or slowly? And then finally, throughput, how much of something happened? So how many table scans were read? How many bytes were sent over SQLnet? This kind of gives you an idea of how much capacity something did, right? So I might do like distance traveled across all those sessions. Did all those vehicles make a long distance in my travel? I might also do something, sorry, I had another one for this now, I forgot it. But I mean, it's something about like, how much did I get at the end of this, right? Did I get to where I was going, sort of? And so if you start thinking about the AWR report in these kind of areas, you can start to see, well, if I see large amounts of weights, that means I need to figure out what I'm waiting on, right? If our resources are being consumed more than what I have, right? Am I seeing larger memory usage than what I have? Then you'll probably see weights that relate to that, right? These two become highly related at some point. Speed and throughput, on the other hand, tell me more about like, was the system running well, right? So for some reason, I might look at speed like, well, did my disk reads and writes at the speed I was expecting, right? Did the cars travel on the freeway at the speed I was expecting? And then throughput, did those statements get across the system in a reasonable manner, right? If I'm reading tons and tons of blocks, but I'm running very few statements, then my throughput's not very good, right? So again, distance traveled, if I have only one car on the road, but it's going 500 miles distance, that's probably not as efficient, right? And then if I had 50 cars in the mile, or 50 cars in the road, each going 10 miles, right? So you'll have to know your system. And that's what we're going to talk about next, is you kind of have to know what this stuff means to you. And going back to our problem with the incident, which one of these types of metrics are the types of metrics they're going to tell you if the incident is related to something that the AWR will help you with. Okay, so here's a bigger snapshot. So here I have 133 cars on the road, and my miles per hour total is 4655, and my average is 35 miles per hour. Miles traveled average is 2 miles per car. They use 0.115 gallons of gas per car, and the average cabin temperature was 70. Did this one car get to the office on time? this one I have asterisk here. I can't tell you with that, right? So again, is an AWR going to tell me that kind of information? No, it's not. It's not going to tell me if an individual statement, or sometimes people come to me and say, hey, this batch job ran long. Is an AWR going to tell me why that batch job ran long? Well, it can't even tell me that it ran long, right? Someone's gonna have to tell me that that car didn't get to the office on time, because the AWR doesn't tell me that. On the second statement there though, do I need to add more lanes to the road? Well, this might tell me that. If I was expecting my average speed to be like 50 miles an hour and it's 35, maybe adding more lanes to the road would help, right? Maybe I can increase the number of CPUs in my box if I'm not getting the throughput of that piece that I want, or the speed that I want, right? Is the miles traveled as I expected, right? Is the number of blocks in cache read more or less than the number of blocks from disk, right? Is that what I would expect to see? And so those are more the kind of things that the AWR can tell me, and I can use these metrics to understand that. But then to make that decision, would adding a lane to this road help? Well, I'm gonna have to know a lot more, right? Just as you probably all know, I could add a lane to this road and everyone could still go 35 miles an hour, right? There's no guarantee. And that's the problem with kind of just looking at this data, is AWR tuning or database tuning is not SQL statement tuning, right? And as you all know, there's probably two ways to solve this problem. When I look at this busy road with 133 cars, I can add more lanes, but I could also reduce the number of cars on the road, right? If I reduce the number of cars, the average speed might go up. And so that's the art of using this information. So here's another example of two different AWRs, and we just want to kind of compare these metrics. So what in the metrics would help you identify the problem. So really comparing two reports, having a baseline is a much better way to know, is that above picture bad or good? I don't know. I mean, is 35 miles an hour average good or bad? Well, if I have another period of the day where I see that the average throughput is much higher, right? And the miles traveled is similar, right? So I'm getting cars the same distance, but my miles per hour is higher. So maybe a different part of the day, I can see that the same amount of data or transactions is kind of going through, but they're going through much quicker. Then I can start comparing these metrics. Okay, now which metric in here is telling me there's a problem, because I have a baseline to go against. And so again, a lot of times you have this incident, right? Someone comes in to me and says, I had this problem last night, here's an AWR, can you help me identify it? Well, the best thing to do is, okay, can you give me an AWR from a time frame that was good, right? The same like batch window or something I could compare, and then I can start seeing what happened that was different, right? Let's see, what's the question? What's difference? Different indicators, metrics, sections in AWR report that show whether DB CPU bound or IO bound with DB is incorrectly configured. Okay, that's a pretty detailed question, but actually in just a couple slides, we're gonna get into those sections and we're gonna talk about how to relate some of those metrics. So I'm gonna get done with my analogy here pretty quickly and we'll hop right into the AWR report itself. But again, this is important to have kind of a baseline. And then this baseline says, hey, if my database is capable of a particular speed and I'm not achieving that, then I can use other metrics. Again, there's lots of instrumentation in Oracle to help me find that out. And so here's just that final kind of analogy example is, can you tell what happened, right? So if I look at these two, and again, an AWR is not this picture. This is the picture of reality. The cars on the road is me giving you like, this is what the reality looks like. But at the end of this, you're going to get average miles per hour, number of cars, and then maybe wait for car time, right? On this lower one, we have 2 lanes blocked. But I bet you our average miles per hour between the top one and the bottom one are very similar. But the number of cars is much lower on the bottom one, and the wait for car time is going to be up. Maybe we have a metric like cars per lane that goes way down, but without having some kind of baseline, I'm not going to know that there's a problem. And without someone kind of telling me, hey, did you know that we had this other issue? The AWR doesn't tell me that there's 2 lanes closed, right? So again, back to that incident, is this going to tell me that there was like 2 lanes closed on the road? AWR report would probably not tell me that. The metrics might lean towards me going, I think there's a problem, right? I might see that this wait time is higher, et cetera, but it didn't explain the problem. It just gave me an indicator towards that problem. And if I take it, Oh, I thought I went there. But if I take it one step further, this is really where that art comes in. I need this data and I need other data. We'll talk about that in just a couple of slides on where can I get other data to help support. Maybe the AWR is a clue, and then this other data will help me find the problem, right? So how do I get help for AWR? So AWR is just this ton of metrics, right? And I think this part of this question is like, okay, there's all these metrics. How do I relate them? How do I do some of that? So ADDM, the automatic database diagnostic monitor, is a automated tool. You can turn this off, by the way, because I've seen some reports recently that didn't have it, and I had to go look up because you can turn it off in the AWR, but it usually is run every time you run an AWR report. It looks at all these metrics and it applies heuristics, right? All these tools are based on heuristics that Oracle has written to look at the data and identify problems. It gives recommendations, and you should take them very seriously. So ADDM gives really good recommendations. Take them seriously, but ADDM is hungry. It will always make recommendations, right? So I showed some different patterns of AWR data with different kind of cars on the road. ADDM is going to try to make recommendations all the time. So what you really want to do is make sure you're looking at workload that's heavy, right? Or workload that's where you think there might be an issue. Then ADDM is probably going to be more accurate. If you're looking at a quiet time, that's good for you to understand the metrics and the baseline, the data, but the ADDM information at a quiet time is probably not as useful as when you have that problem going on. And so one of the things ADDM does is it helps relate metrics. And so if you're seeing a problem, like this is the time frame where the throughput was lower than it should be, or the batch job had issues, the ADDM info is probably better at helping relate, like, I see this weight, and that weight relates to the following, maybe disk IO or CPU weight, which means you should probably like reorg this table or increase your SGA. So then those recommendations are probably better. Again, the recommendations, you really do need to analyze them and take them a step further, but they are pretty good recommendations a lot of times if the workload it's looking at is realistic. Okay, so types of AWR reports, just to kind of get this out of the way, there's standard reports, single instance. There's rack reports, which is global, multi-instance. There is individual SQL statement reports. So in AWR, you'll have your top SQL statements. You can run a report on an individual SQL statement, and it gives you a lot more detail about that singular SQL statement. There's also comparison reports, which I think a lot of people forget about. These are super useful. There's single instance comparison, and there's rack or global. Oh, I just noticed these two are reversed. The G should be down here for global, and the D should be up here, but the D for difference or comparison report. This takes the data from two different reports, and we'll show an example here real quick, and compares them for you. So, of those 2,000 metrics, you don't have to compare them. It'll compare them for you and then give you that information. By the way, you can take AWR data from two different databases, put them in the same repository, and run different reports. So maybe you have production and you've cloned it or brought it to another system, and you've upgraded the hardware, upgraded that database to a new version, and you've run your tests, and now you want to compare those reports. You can bring that data together and compare them. If you're using a tool like RAT, Real Application Testing, that's exactly what RAT does. Part of RAT's output is a compared AWR report with some analysis, with an ADDM run against it that says, hey, I ran the comparison and here's what I saw. So just don't forget about those comparison reports. They're very helpful. Also look at the DBMS Workload Repository PL/SQL package. You can run these manually through PL/SQL. You don't have to use the scripts. The scripts call this package, just to be clear. Okay, so this comparison report, here's a quick example. So here's maybe, I have this set, and that's the same thing that this comparison report is doing. Is I have my first set of information and my second set, and then giving me the difference, right? You can see it actually has the different metrics, the differences, and then all those different things on as far as here's the average weights per second, total waits time. So this is that cumulative, and then average weights, right? So again, these are cumulative metrics. That's the center one, and then the averages shown out. Just note when you do rack instances, this is aggregated, right? So if you have 2 or 3 nodes in your rack, it's summing up those metrics across the rack nodes and then comparing them as a summary, right? So when you do the global one in a diff report, it's a cumulative metric. When you do the standalone reports for a global, you see each instance and then a cumulative number. So just know that when you do the diff, it's always a cumulative for a rack. Yes, and then here, it's a subtle change. It's a very subtle change in this picture, but notice in the first report here, we have X number of cars and buses and things. Next one, we have X number of cars and buses, and then we have the closed lanes. Now, what if that second one was like way more trucks and buses and way less cars? Again, this is the kind of stuff that I just want to amplify. The metrics are cumulative, right? So if these buses are doing huge amounts of buffer reads, way more than these individual cars are doing, but the averages might look very similar. So again, back to what does an AWR tell me? It may not tell me the difference between a freeway full of buses and a freeway full of cars unless I look at some of the very specific metrics that talk about number of statements parsed or number of executions, et cetera. But the number of like bytes transferred might be the same. Okay, so let's get into those sections of the AWR report and then talk about how they relate to each other. So when you open your HTML page, you'll have these sections, and I'm just gonna kind of talk through them quickly. The header section, these are the parameters used to generate the report. What databases, what instances, what servers are they on, what times did they run from, snapshot numbers, et cetera. The report summary, these are key metrics, and we'll talk about that next slide, what kind of key metrics. This is where you start your investigation. This is kind of like what was going on. So on those other pictures, talk about how many cars are on the road, how much total throughput, how many miles total did they travel, et cetera. That's some of that report summary. The main report, this is everything collected, those thousands of metrics, all that were collected is in the main report section. And then if you're doing rack, there's a rack section with the rack specific. Again, if ADDM is enabled, you will see an ADDM task. In the report summary, there'll be an ADDM summary if it's run, but the actual full task will be lower down in the report. Okay, so what do I start looking for? In the top ADDM findings, what did ADDM see in that snapshot? What are there, and the details are going to be down in that detailed section, but what did ADDM, did it say like, hey, I see high IO weight, or I see a particular SQL statement that's consuming more than its share of the time. There's one bus on the road blocking 3 lanes, right? ADM's pretty good at finding a lot of these things, right? So that's where I'm going to start and just see what it says. The load profile section. How much work did the database do during this period? How many bytes did it go? How much CPU did it use? Is this a period of heavy workload or light workload, right? And we'll talk about that in, I think, the next slide about how to maybe calculate that. But you know, if it's a light workload period, then some of the high-level metrics in this report aren't going to be as useful, right? Average disk IO time, et cetera. I will look at those, but if it's a light usage period, those probably aren't the most useful metrics because the system's not under heavy load. The system's not being pushed to do a lot of activity. In that case, then this AWR might be more useful to find bad SQL statements or maybe things that are, you know, truly those outliers, right? If even in a light workload period, something bad is happening, then I should fix that, right? Because under heavy workload, those slightly bad things become really bad things. The instance efficiency section, these are well-known ratios, right? So this might be like your buffer cache hit ratio, et cetera. In the old days, these were where we started. In this day and age, you know, these should be pretty good, right? Your buffer cache hit ratio should be in the 90 percentiles, et cetera, right? Things like that. If these are way off, you know, then tuning 101 needs to kind of kick in, right? You're low on your buffer memory, things like that. So I usually look at these, but I just go past them unless there's some other fundamental problem, right? Your mileage is going to vary in these, but you know, again, if it's a light workload, these might be low because it's just light workload. But if it's a representative workload, you should be seeing these things be pretty good. And then the top 10 foreground weight events, yeah, this is kind of important, right? This is that DB time model. Where did my database spend its time doing work? The only downside about this is sometimes the database just has to do work. So the highest workload time item here might be okay, right? So maybe it spent most of its time just reading buffer cache. That might be okay, because maybe that was what the database needed to do. On the flip side, if this is like spent a lot of my time waiting to write to redo logs, well, then that's probably a problem, right? I need to increase my redo logs, or I spent a lot of time waiting for sequence cache. Well, you should spend like 0 time waiting for sequence cache, right? That's the whole point of caching. So these are very important to look at, but again, it depends on the weight and what you see. And this is where baselining can be very important to understand. Coleman, I see you have a question. Oh, wait, here we go. How do you know whether ADDM is disabled? I didn't put that in here. I will try to add some information on that. ADDM it's enabled by default. When you run the reports, there's a feature on the report run that you can say, don't run ADDM. It's a SQL variable, or when you call the package. The other piece to disable ADDM, I believe it's there's a database parameter if you disable it. So that's the two I know off the top of my head, but I will find some more information on that and make sure we document that. Okay, just a quick note on metrics. You're going to be just a ton of metrics in AWR. So know what you're looking at, right? When you see this S nomenclature, that's generally seconds, MS milliseconds, and the US, and it's a U with a little tail on it. That's microseconds, right? And you really have to watch this. I had some reports recently in the last few years. You see a lot more of these microseconds showing up in the reports, especially on like Exadata systems, et cetera. So just make sure you're watching your numbers and when you compare them, right? So this 718 microseconds is about 7 milliseconds, okay, just to be clear. So make sure you're watching your numbers and metrics. In the data columns, if it's got an MGT or P, those are increments of 1024, right? So if it says bytes written, 5,000 G, that's 5,000 gigabytes. In other columns, it might say session count, and the session count might be 4K, then that means 4,000, right? So just be careful on the metrics you're looking at. It will put summaries right here, says write pieces, backup write pieces. That's not bytes, that's K, that's 17.8 thousand. So you don't multiply that times 1024. It's only in the ones that say data that you do the 1024, okay? So again, just how to read the metrics in the AWR report. In the load profile section, so this is early on in that summary part that's kind of telling me how much work did my database do. I am looking at these kind of things. Database time per transaction, right? So if there were so many transactions, how much database time per transaction was kind of spent. And if it's not a good number, then I'm like, okay, then we're waiting on something, right? The database wasn't spending the time on the transaction, it was spending the time on something else, maybe a backup, something else was running. CPU time per transaction, again, is most of my CPU time going to the work of the SQL statements that the application is running, or is my CPU time going somewhere else? So again, I'm just looking at that time and trying to decide how much is there. Logical reads and writes and physical reads and writes. Do those make sense, right? So logical means anything in cache and memory, and physical disk, right? So those numbers, I'm hoping to see more things read and write logically in memory than disk. I'm also kind of wondering, again, this is a baseline thing, if last night during this time window, those numbers were smaller and tonight they're higher, and then tonight we had an issue, I would look at something like that and say, well, wow, our reads or writes were way up. And then the IO request, this is quantity to disk, and this gets into depending on what type of disk you have, right? So if I'm doing a lot of IO to disks, then I want to make sure my disks are spread out correctly. I want to make sure my disks have asynchronous IO. I make sure I'm using things like ASM. If I'm doing a file system and I have a concatenated volume manager on top of it, then I'm going to really watch this kind of stuff, because IO requests to a file system have buffers, and there's file system queues that limit that, et cetera. So these numbers become very useful in those areas. And then finally, parses of SQL, how many SQLs got sent and parsed, and did they get reparsed, et cetera. So this talks to application efficiency. Was my application written well? Are they using bind variables? This just gives me a hint for that. And again, having a baseline to compare that to is really important. Sorry, I'm looking at the question here real quick. So why I use AWR versus Ash? Great, we're going to talk about that. I think I might get to run a couple minutes over here, guys. So I'm sorry about that, but we'll talk about that in just a couple slides on Ash versus AWR. So again, let's just look at that load profile. And here I'm using a diff between two AWR reports. And I'll mention at the end real quick, but you notice right here, you can see my CPU on the first and on the second, and you can see my CPU time went down. My number of user calls here went up between the first and the second. And my number of executions went up between the first and the second, right? So I actually did 29% more on the second, and I did more less database time per each. So you really got to look at these numbers. Notice the diffs are kind of interesting. It uses the first as the baseline. And so you can see in some cases, you know, the first one is smaller, but like number of executions, that means I did more work, right? The number of executions went up, whereas CPU time went down. So I did more work and I used less CPU, okay? So you got to kind of learn how to read these. And this is why it's important to be starting with the load profile and say, am I comparing apples to apples? In this particular case, this customer moved from an older Exadata to a newer Exadata, which means higher speed processors. So I would expect something like CPU to go down, and I might expect executions to go up, right? So there's a lot of ifs in these, but that's, you know, when you're comparing these reports, make sure you know what you're comparing. When I get to those top 10 foreground wait events, I'm going to start looking at these ranked items, right? So I'm looking at this, like how much time was spent in CPU, and you can see that the next highest one is log file sync. So this database probably needs a little help with its log file sizing, right? It's either the IO or the sizing might not be where we want because it's the #1 wait. Can I make that smaller? I don't know. And so the question was why look at AWR data versus ASH data? This is a situation where AWR data is going to help me identify I might need to fix my log file sizes. ASH data will probably not help me as much. On the flip side, if this is syncing poorly because someone wrote a bad PL SQL code that's doing tons and tons of individual row by row commits, ASH might help me see that, right? So it kind of depends which side we're looking at. Just realize this time number is relative, right? So this is a 1 hour snapshot, and I have 128,000 seconds here of time right here. So 128,000 seconds. You're like, how can I have 120,000 seconds of time in an hour? It's because it's based on the number of CPUs. This particular box had 90 cores. So technically, there's 324,000 seconds of compute power available per hour because it's 90 times 60 times 60. That's how much compute power is available. So 128,000 of that was used by the database. These are statistical numbers. These are averages. Don't get super hung up on the exactness, but you can do interesting things like this and say, well, I had 128,000 of 324. So my database used something around 39% of the CPU on this box. And then if I go down and I look at, well, what was the OS usage at that time? Well, it was about 43% busy at the beginning and 43% busy at the end. So my database was using most of that operating system. Just realize these are individual snapshots. These are not averages. This is at the beginning and end of the usage. So, you know, you may then go get into like OEM and look at your CPU usage across that hour, other things. But again, this is just ways to compare that data and help me know, okay, does this number make sense? If I was using this amount of time to do DB work, was the operating system responding correctly, right? Because again, back to my picture, if through 2 lanes were closed, is the AWR going to tell me that? No, but I can use some of this data to go, well, does things look healthy? In this case, yeah, this looks pretty healthy. The next thing here, you're going to say, well, that log file sync was 12,000 seconds of the 128. And then I can ask myself, so if I can get that log file sync time down, then I could get 10% of my CPU time here back. Well, the box wasn't saturated, so I won't make the box super quieter. I might only make the box a little quieter, but I might help the SQL run faster, right? So again, these are things that AWR can tell me that ASH data cannot. Some quick problems with AWR. So AWR always has data. So I've had people send me reports when there's like nothing going on and say, is my database efficient? Well, if 3 cars drive down the road and they all doing the speed limit, I can't tell you a whole lot, right? The same thing with like a big batch job, right? So here's a big batch job, just sitting in that right lane, going 45 miles an hour, just doing tons of data processing. That does not tell me if your database is efficient, but AWR will still have data in that case. Oh, we got some more questions here showing up. Let's see. What's the best way to interpret we histograms? Not sure what we is. Let's see what that for there. Is there an AWR type report that covers all the CDBs running and the node server? Okay, let's talk about CDBs just for a moment because I did not put a slide here on that, and I probably should add that for future sessions. The default in 12.1, AWRs are captured at the container database level. So if you think of this road analogy, it kind of makes sense, right? And AWR is all of this traffic going on, and that's what the initial intention was. PDBs do capture AWR data. And so in 12.2 and above, you can do PDB only reports. You do have to turn that feature on, and I don't have that in here, but there's a feature you can turn on to get PDB only reports. But just realize if you're looking at like my instance efficiency across the whole system, which is kind of what I'm trying to show with this traffic diagram, that's what the AWR is for. If you think of like a CDB, maybe a CDB is these two lanes. Yes, you can get CDB level reporting. You have to turn a parameter on. You can run AWR reports at that point. The problem is you don't know like if this lane was having issues or this lane was causing impact on that. You're not going to see that in that CDB report, right? The CDB report is going to be what happened to the sessions in my CDB, and I don't know what's going on in the other ones. And so that's why the PDB, I keep doing that. PDB is what happened to my PDB. The CDB is what happened to everybody, and it includes the PDB level data. But that's kind of how that's split out. So that's a really great question. So let's get in quickly with ASH. I got a few slides left. So I'm sorry I'm a few minutes over, but let's get into ASH quick, and then I'll try to answer any open questions I didn't get to. So what's ASH then? Active session history. This captures statement level details, SQL ID for any session that's non-idle. It captures data every 1 second. So if you thought of AWR as like I capture database level data at this interval every 1 hour or every 30 minutes, et cetera, ASH captures data every 1 second for anything that's actively processing. If it's idle, it ignores it. There's an internal buffer in memory called the ASH buffer, and it's a rolling buffer, a circular buffer. So it keeps pushing data in there. And when it's full, it just pushes out old data, and that buffer just keeps rotating on top of each other. AWR data summarizes that. So ASH is pushed into AWR every 10 seconds as a cumulative metric. So when you're running historical ASH reports, things that aren't in the current ring buffer that's in memory, you're getting 10-second data. And that's why I said that report I was showing from OEM, I'm not positive that report is at the 10-second level, but the most granular you can get for anything outside of current memory is 10 seconds. Generally, ASH history in memory, you're talking 45 minutes, an hour, maybe a little more. It kind of depends on your system. Again, I didn't go into here because this is not an ASH presentation, but there are settings to change your ASH buffer size. It's pretty good by default. Your mileage will vary. It's an underscore parameter to change it. Not saying you should, but that's what ASH is. It's really this information at the session. It's very good for mining individual statement information. And so here's a quick example using the same analogy. If I have these sessions and they're running statements, ASH is grabbing, notice these at 1 second intervals. Here's my miles per hour. Notice before I was getting an average miles per hour for that whole hour. Here now I'm getting this statement ran 55 miles per hour here, 60 miles per hour here, 40 miles per hour here. And then it was idle, right? It didn't do anything at those moments. So ASH is a very different, and then it rolls over every 10 seconds. So then 10 of these samples will get averaged and roll over to that AWR data. So here's that big difference, SQL tuning versus database tuning. If I'm tuning SQL, I'm working on my car, or my trip, my route to work, right? I'm reducing gas consumption, I'm increasing the maximum speed, I'm changing my route to get there quicker. When I'm working on AWR, I'm working on the road. Can I increase the speed limit? Can I increase the number of lanes? Can I put some limits in? Hey, buses, stay in the right lane. Motorcycles, drive on the line, I guess maybe is your option, et cetera. Can I put express lanes in, et cetera? That's what my AWR is for. So this is the big difference. ASH is much more of tuning that car. ASH can help. I mean, sometimes you have this incident, ASH can help you find that incident. Craig Schelmer does a great session about that. And maybe you can find a bad SQL statement that needs to be tuned, or maybe it points to a database problem like sequence caching, et cetera. But AWR probably points to sequence cache problems already, right? There are lots of other tools. So I'm not going to go through all these, but there's lots of other tools when you have these incidents. So when you have an incident, make sure you know what tools are out there. And by the way, Oracle simplified this for you by creating something called the Autonomous Health Framework. And so when you have an issue, like a slow database, there's all these things you should collect, right? AHF, the Autonomous Health Framework, used to be called TFA. You should absolutely be installing it. You should actually be running it. Sean Scott, our team, does a really great session about AHF. He's one of the experts on that tool in our field. Make sure you have this available and up to date. It helps you do all this stuff. Make sure you know how to use these tools. I don't know how many customers they've run into, they have an incident, and the first thing we have to teach them is how to collect data from their incident. And like I said, AHF makes this easy. When you have a DB perf issue, you could run TFA collect, diag collect, SRDC, DB perf. And it'll ask you for a time frame, or you can add a time frame on the end, or you can run it right now while the incident's happening. This will collect that stuff for you. Again, SQL performance issue, a database hang, or a 60 deadlock, you can combine these. But just to give you a quick rundown, when you do a DB performance collection, it collects for you automatically all of this. All of this is collected and zipped up. Oracle will say, put it in a support note. We usually ask our customers, we're helping them send me that TFA, because we will dig in and look at the AWR report or stats pack that it pulls. We will look at the ASH reports. We will look at the OS Watcher data, et cetera, et cetera, et cetera. This is in and collected for you automatically. Now, so when you have that incident and the boss says, do we have what we need to fix that problem or find what it is? This is the tool, AHF, to do that. And again, it does different collections for SQL performance or deadlock issues. Lots of good notes on that. So with that, hopefully this story, this journey has talked to you about kind of how metrics are collected, how they get into AWR, how to use some of those metrics because you maybe better understand what they're for, and some of the differences between like ASH and AWR and some of these other tools that can help us diagnose a problem. And with that, I will thank you all for coming. Please keep in touch with us, and I'm going to hop into any open questions I can get to here while you guys hang on. So thank you all for staying a few minutes late. So again, the question was on ASH versus AWR. I hope I covered that. ASH is really session-specific SQL statement data. It's way more granular. AWR is really that database level metric, accumulation, averages, you know, I'm looking at the freeway as a whole versus looking for individual cars or trips. We talked about the CDBs. Oh, wait event histograms. Sorry, yeah. So the question was, is there a way to interpret wait event histograms? Yes, I could cover that. I don't have one up on my screen, but if you've seen, I do another talk and I talk about performance. Let's just talk really quick about what a histogram is. So a histogram is a statistical term for a way to interpret data. If you've seen a USA Today graph or something, most of those are histograms, right? Number of people that like cheese on their hamburger, and they might have cheddar cheese, Swiss cheese, provolone cheese, etc. Those different bars, that's a histogram. The buckets are the types of cheese, right? So a histogram is just buckets of things and then individual amounts of how many of those occur. So the weight event histograms is saying, here's a histogram, a weight, and then here's how much it occurred. And so those numbers, you're supposed to be looking for the numbers that are bigger in that list than the others. Unfortunately, Oracle AWR doesn't have a graphing. So instead of looking for tall bars, we're looking for big numbers, right? So for weights that occur less than 2 seconds, which ones occurred the most quantity, right? You know, that's the histogram across the thing. It says these buckets contain the most amounts, right? So that's the buckets across. So that's the idea of the weight event histogram. What about multiple CDBs on a node? Okay, so that's a really great question too. When I'm performance tuning multiple databases that are shared infrastructure, I'm gonna pull AWR reports from each of them and look at them from the same time frame. This is where you might bring up Excel and start taking some key metrics and putting them together. Note that example I gave back here. If I see this, like here's my time I spent, and then this is at like 99% utilization, and I'm using 39%, then I know something else is going on, right? This is how, these are indicators, these are not evidence, right? This is indicator that I need to go look at maybe OS Watcher black box data and see what the CPU is doing, or OEM server metrics, or hey, there's another database on here. This was not the culprit, right? If someone says, we had a big performance spike on the server last night, and I go run this AWR, I can just look right here and go, well, this guy only used 39% of the server, someone else I need to go look for, right? So that's when I'm having multiple CDBs or multiple databases sharing instances, sharing the same server, I need multiple AWRs. And Yeah, never mind. Diffing them isn't very helpful. There's a new tool called AWR Repository. You can pull more of this data together, but you're still gonna have to run each report independently. I don't think they have a summarization model there yet. With a high number indicate an issue, what to do about would a SQL statement in SQL ordered by executions with a high number indicate an issue and what to do about it? That is a super loaded question. I guess my comment there is, so you have a SQL statement, it has a high number of executions. If you're FedEx and that SQL statement says, is someone shipping a package? Then I probably want a high number of executions because we're FedEx and we ship packages. If I'm FedEx and the SQL statement is, are my table spaces full? And it has a high number of executions, I probably want to visit and say, why are you checking my table space full every second or something, right? So it's a very loaded question, and that's kind of why you have to know a little bit more than just the metric. I see the importance of creating baselines. What would you recommend? Snapshot X hours each of generally busy day. So this kind of gets into if I'm doing hourly or half-hour snapshots and I'm looking for a baseline. I can tell you, I've worked with many DBAs. One of them, what he used to do was the application was kind of a US-based application to start with. So, you know, if you think like 7 a.m., sorry, I'll say 8 a.m. Eastern, and then going out to Pacific time frame, right? So then you would get to about 8 p.m. Eastern. He would run an AWR report daily for that range and then save them off. He had set up a job that just emailed it to him and he would save them to a folder. And then when Europe started to come online, he increased that window, but now he knew what the system load was when it was just US. And when Europe came online, he could compare that. He also started making windows that were ranged, like Europe and US kind of overlap generally during that 7 a.m. Eastern to about 9 a.m. Eastern timeframe. There's a big overlap. So then he would make targeted reports for things like that. But that's something you learn over time, right? You kind of have to know your system. If you have like an online window and maybe you have a batch window, maybe you'll set a separate report, AWR report for that batch window, right? But that doesn't affect your snapshotting, right? Your snapshotting, you have to decide if 1 hour or 30 minutes or 50 minutes is the metric level that you want to see things at. Okay, how to fix the cursor pin as wait on next event. I can't tell you how to fix that event on this session. There's a whole bunch of cursor pin wait on S events type problems, so it's not a one-time fix, unfortunately. Sorry, but you can try Craig Shellhammer's new Q&A chatbot. Go check out OraPub. He's got a chatbot that he started putting a lot of his historical training into. So, with that, I think I'm close to the end of the questions. I think I did pretty good there. I don't know. Rob or Coleman, anything else you guys want to say? Coleman just says bravo in the chat. Thank you. Thank you.
Just thanks a lot, Gary, for being part of the webinar today. And we're looking forward for future webinars from you, Gary, and from your team. Thank you again, Viscosity.
Absolutely.
Gary.
Yeah, thank you, Gary.
Thank you
Thank
so
you very
much,
much.
guys. And for everyone else, yes, this was recorded. Again, you'll get to be able to view it through www.orapub.com. Gary will get the slides from you and any other resources you may want to share with everybody. And we'll have that all on OraPub for you guys to view within the next 24 to 48 hours. So just look for an email from me. But otherwise, thank you guys so much. See you at the next
Thank you, everybody.
webinar. Take care.